Okay, so here's the video for number 3 and number 4. Um, you will realize that this ends up being almost identical to number 1 and number 2. So we'll go quickly here. So we'll start on number 3. Now we're doing a Ferris wheel. 60-kilogram passenger rides on a Ferris wheel, is moving with tangential speed of 4.75 meters per second. Ferris wheel, our seats are at the end of stress are 6.5 meters from the center of the ride. So there's your radius right there. Your velocity, your tangential speed is right there, the 4.75, and you got the mass. So the first thing is, what's the centripetal force and the weight of the passenger? This is exactly like the last problem, so we can do this here pretty quickly. So number 3, so the centripetal force would just be the mass times AC, which is the mass times V squared over R. Well, at this point, the mass is 60. The velocity, that's a 60. The velocity is 4.75. Yep. So it's 4.75, and that's squared over the 6.5 meters, which was the radius. I'm just double checking. Yes, that is in fact what it is. So the FC ends up being, hold on, I got to go to the calculator here. 60 times 4.75 squared divided by 6.5, and I'm getting 208 newtons. Let me double check that because I'm just not trusting myself because I'm half asleep while I'm doing this. All right, 208 newtons, that's what I get. All right, so then the second part, part B, was what is the weight? Again, weight is just Fg. Make sure you know that weight is the force of gravity. This will be just 60 times 9.8. That's supposed to be an 8. Sorry, that looks hideous. But you know what it is, 60 times 9.8, 60 times 9.8, and we get 588 newtons. So there's part A, there's part B, done and done. So now we come back up and look at part C. What's the normal force at the top of the ride? And then, of course, part D is what's the normal force at the bottom of the ride. So again, very similar to the last problem, will be slightly different because our free body diagram is different. So need to get, there we go, C right there. So a Ferris wheel, would that be a ball on a string or a Ferris wheel? Again, please don't think too hard on that one. So this is a Ferris wheel. If you recall, they'll have a force of gravity down and a normal force up. Now, we know the force of gravity is 588. We don't know what this is yet, but we do know that the centripetal force is equal to, I believe we got 208. Let's go up and check real quick. Yep, 208. So we know that this is equal to 208. And we know that that's equal to the force of gravity, which is positive, by the way, up here, and the normal force will be negative. So we get a 588 plus the normal force. And we solve for the normal force, and we get real quickly a negative 380. Negative 380 newtons. And so for all you sig fig sticklers, there's the bar. Okay, so negative 380 newtons, that's a negative. And that's our normal force at the top. Now, our normal force down at the bottom, all right, if we draw this again, well, our force of gravity will be down, but this time it's negative because it's pointing away from the center of the circle because it's at the bottom of the circle, and it's 588. And we know our normal force has got to be bigger now. And we got to figure out what that is. We know the centripetal force is still a positive. This is why we make the center. It's always positive 208 is equal to negative 588 plus the normal force. Sorry, I'm running out of room on my screen, so I'm going to have to, I'll clean that up. That's just not very, yeah, let's just clean that up. And here we go. 588 plus the normal. And so if we just solve for norm, F norm, we get, let's see, we get 208. 796 is our normal force at the bottom of the circle. So there's number 3. Again, number 3, not too difficult there. Pretty straightforward. All right, let's go on down and let's start number 4. Okay, so let's go look at the problem first. A passenger rides on a Ferris wheel, which the seats are 6.5 meters from the center of the ride. A, what speed must the Ferris wheel have so the passenger will feel weightless at the top of the circle? All right, so let's go look at this. This is fun. No mass, doesn't matter. All right, so we're looking at the top of the circle here. So we got the force of gravity down. Now remember, we feel other forces. We don't feel gravity. So what's this normal force got to be equal to? Well, it has to be equal to nothing. So that means the centripetal force is equal to the force of gravity. Well, that means mass times the centripetal acceleration is mass times the acceleration of gravity. Masses cancel. So we just get v squared over r equals our g multiplied by r, that's a g, by r, square root, velocity ends up being the square root of g times r. So this ends up being 9.8 times our radius, which is still the same Ferris wheel. So it's 6.5. So calculator time, this ends up being 9.8 times 6.5. And we need to square root that. So square rooting 7.98. We get 7.98 meters per second. So the passenger will feel their rear end come out of the chair just slightly at the top. They will feel no pressure between their rear end and the chair, and they will feel weightless. So that's where you get there. Now, B, at this speed, what is the normal force of the passenger at the top of the ride? We know the answer to this. We just talked about it. We just showed you right here. It's got to be 0. So the answer to B is the normal force will be 0. So we can write that in. B is F norm equals 0 newtons. Okay, next. Part C. At this speed, how does the normal force on the passenger feel on the bottom of the ride? How does the passenger feel at this point? So what we need to find is the normal force at the bottom of the ride. You probably, I'm hoping, know the answer to this already. But if you don't, that's okay. We'll figure it out. So we'll have our force of gravity down. We'll have our normal force up. And since they didn't give me a mass, I have to get a little creative how I'm going to have to figure this out. Okay. All I know is that the force of the centripetal force is equal to the force of gravity. So I know that Fc is equal to the force of gravity, or it's equal to the magnitude, and it's got to be positive, so it's a positive force of gravity. We also know that it's equal to the force of gravity plus the normal force. Well, it'll be the force of gravity, which would be negative here, so I'm talking about that one there. Here I'm just talking about magnitude plus the force norm. All right, we solve for F norm, and what we get is it comes out to be 2 times the force of gravity. So at the bottom of the ride, the passenger feels twice as heavy as they normally would. So that's what they feel at the bottom of the ride. Part D, does the speed represent a minimum or maximum speed? What will happen if the speed of the Ferris wheel is increased? Okay, so this is a maximum. You can't go faster than this. If you go faster than this, what ends up happening is the passenger that's sitting there, the only force down is gravity, but the centripetal force needed ends up being more than gravity. And so the passenger becomes a projectile. They go flying out of the Ferris wheel and